All right, so my name's Emmanuel Lwele, and I'm with Hallam University and with the Institute of National Center of Excellency for Food Engineering. Okay, so my presentation is going to be really short because we're just trying to look at how we're trying to apply digital twins to the manufacturing industry. All right, so our previous presenters have done a very good job about introducing what digital twins are and the direction in which we are actually going to. And at Sheffield, thank you very much, Chris, for allowing me to do this. Uh, One of the applications of digital twins is previous presenters have talked about is creating a digital model of an actual physical entity. So our application of what we're actually looking at is a rice machine. So I'm sure most of you eat rice or use rice as part of your meals. So we're trying to look at a rice milling machine. I know we don't have the whole chamber of what we're supposed to look like because my presentation is actually supposed to be under 5. So uh, this is mainly what we are trying to do. So the creation of digital twins is actually like a buzzword right now, and everybody's trying to look at how we can use digital twins to develop and apply it in the new smart cities and various applications. Um, One of the things of what we're trying to look at is how can we use digital twins for prediction maintenance. And apart from that, trying to achieve net zero, then we are also looking at how we can simplify these digital twins. And that's where this project comes in, where we're trying to employ what I refer to as surrogate models to actually implement a new digital twin. In this case, we're trying to refer to as AI-based surrogate model. So the reason why is the computational power that is actually needed to create a digital twin is very expensive to run. And when it comes to industrial application, that can cost a lot. So one of the things that actually is in place right now and more research is being done is how can we use surrogate models, in this case, statistical computational models, to actually build a digital twin and then try to implement it and lessen the computational power needed and the expense to build that digital model. So I'll do a brief explanation of what we're doing is we have a rice milling chamber, and different quality of rice requires different external factors for you to mill that rice. So an example I would give is if rice was milled in different parts of Asia, different parts of Africa, for you to mill it to the quality of rice that you need for different types, like pudding and everything, you will need different temperature, humidity sensors for you to actually mill that rice. So with the implementation of surrogate models, depending on the data that we collect with the machine, we're trying to build a surrogate model for the inside chamber process of what takes place in that rice machine, and that's where surrogate models come in. The reason why we're doing this is surrogate models are lightweight computational models, and they can actually help in running these digital twins at a very efficient and lessened cost. So I wish I would have shown you the rice machine we're working with, but since digital twins have been explained and implemented, the main thing that I would want us to look at is mainly what the area of the research is. So this is being implemented here in Sheffield, and um, in case you want to know more about the implementation of where we're using this, you can actually contact me after the, the presentation. So we're looking at creating lightweight machine learning based surrogate models to implement for a real world scenario. In this case, we're using it on a rice machine. So once this application has been implemented and we see the outcome and the computational cost, then it can be implemented on various applications of where digital twins is being driven to, like the research, like most of the research goes into self-driving cars and smart cities and all that. All right, I think that's all. Thank you.